you're taking as inputs, and then you're framing your published models. So next, here, this is a brief classification. Later we will have a detailed classification. So that is here, they are dividing into main two branches. So that is approximate reasoning and search optimization method. So that is an approximation. So here, everything is going to be certain approximation, like you know very well about what is probabilistic theory and fuzzy theory. So probabilistic theory where your input is unknown, whereas in fuzzy logic, it's a partially known. That is the main difference between your probability and fuzzy theory. Later we will go in detail about the fuzzy theory and neural networks. So search and optimization techniques, your neural networks and evolutionary algorithms are the best methods for optimization. So when you say the word, when you use the word, wherever reasoning comes, your fuzzy dominates. Wherever optimization comes, your neural network evolutionary algorithms dominates. So you need to remember what is my area. If I'm going for any thinking, like, so my system has to take decision based upon certain reason, then you need to use fuzzy logic. So your system requires an optimized solution, then you need to go for neural network and evolutionary algorithms. So now, what are the main techniques? You have computing techniques. We have hard computing and soft computing. So in hard computing means precise models, whereas soft computing means approximate models. So why I'm saying like this means the hard computing is nothing but this is the theory which have been segregated as hard computing and soft computing. But in general, you know very well about this. So for example, you're framing your problem in a mathematical way, and you are using certain solutions like differential equations. For example, you want to calculate what is the your maximum value point at a curve. For example, there is a function, so you want to find out at which point the maximum value will occur. So you're going to find and you're going to draw the tangent, and wherever it is going to touch us it, so you're finding the maximum value. So it's mathematical approach. So that which is nothing but a hard computing, where your inputs are certain. Certain means they are fully known. Whereas in soft computing, when you are applying this soft computing, your inputs are uncertain and imprecision. Okay. Here are the clear differences between your soft computing and hard computing. So about the basic. So just now we discussed about the basics. So next, you're based on fuzzy logic, probabilistic theory comes under your soft computing. Binary logic system. This means, for example, in an interview, somebody is questioning you some question. So you have to say either it is, you need to give the, say for example, what is the capital city of India? So you need to give exact answer. That is, your Delhi is the capital city of India. So it means that you need to give the exact answer for a particular question, which are called crisp logic. And crisp logic means where you have perfect answer. Either it is yes or no. That's it. There is nothing in the middle. So whereas in soft computing, where we are taking approximate, so you need to remember the words precise and approximate. Precise means it's a perfect, exact. We can say exact. When you come to the soft computing, it's approximate. It means that nearer values. So always we will have non-linear problems in the world. So you may ask, like, when your hard computing is giving, see for example, if you observe the result or computation, so your output is very exact in your hard computing. So works on, see here you can see like here result, approximate result you will get. Whereas here it produces precise outcome. Precise means you will get very exact outcome. So you can ask me then why we are going for soft computing. So the reason is that when your real world problems or your research problems are not linear or exact input known areas. So your input is unknown, like weather forecast. Your weather, we cannot, today is sunny day and tomorrow is you will have rainy day. So because the input is uncertain. So in such case, we can say those kind of situations as a non-linear things. So for the non-linear things, soft computing is going to be used as a best model for any kind of your non-linear kind of things. Okay, so here are a few of the differences, like features, like its approximation. It goes through the approximation. It categorizes and precision means exact value. Something like you're taking some boundary. So if it is above this value, you are fixing certain threshold value. So then only you're allowing it, otherwise you're rejecting it. So that kind of logic will be comes under your hard computing because you're exactly fixing this. So whereas your soft computing, you're allowing the nearer values also from this region. Okay, that is approximation. Next, nature is stochastic nature and deterministic. Deterministic means your exact values you're consulting, whereas stochastic means your statistical data approaches has been considered to taken into consideration. Okay, so next, it works on ambiguous and noise data. It just now I told you, right? So your input is unknown, which is exact thing. Whereas in soft computing, it's ambiguous, uncertain. We can say uncertain. See, for example, working on solar integration. So the how to maximum power point tracking. One of the area in solar integration is maximum power point tracking, where you are mostly focusing on highest output generation, because you don't know what is the exact that is radiation falling on the your solar plate. So because the input coming from the light from the sun is not a deterministic or precise one. It's ambiguous. It means that it is undetermined. It is determined, but it is approximation. It means that it is not a non-linear kind of. It's linear. So you cannot say like we have soft computing techniques as fuzzy logic, neural network, swarm intelligence, evolutionary algorithms. Now these are the classification given by one particular reference which I have taken, which is the most preferable, and most of the people have cited more. So that's why I'm following this particular classification, because you're seeing different classifications. If you see one particular research paper, so they will give you soft computing technique means only fuzzy logic, neural networks, genetic algorithm. If you see another classification, there they will give you fuzzy logic, neural networks, and evolutionary algorithms. Then if you see some other areas, they will give you approximate models and precision models, like which I have shown you in the second slide. So this is the detailed one which has to be considered, because it covers all the things which comes under soft computing techniques. So your machine learning in the sense, when you go for your artificial intelligence, obviously it comes under neural networks. Next, fuzzy logic, the fuzziness, reasoning. We can say reasoning. So neural networks, adaptability, fuzzy logic, it's reasoning. Next, evolutionary computation, that is evolutionary in the sense it indicates a genetic algorithm, and you have evolutionary differential evolutionary algorithm, and you have some more algorithms also. We will come across that. So mainly used algorithms are genetic algorithms and differential evolutionary algorithms. And next, swarm intelligence, we need to discuss a lot in this. And you had a session on this, like nature-inspired algorithms by Joshi Manohar sir. So there are other methods also available in this, and then probability reasoning. So this also comes under your soft computing techniques. So now, what we will next? This is another way of classification, which I told you. That is the one detailed one, and this is another detailed one. So here you can have an idea which comes under what, and what are the different algorithms available. Because if you are implementing one particular research, so almost all the researchers have been implemented, then you need to go for a hybrid kind of thing. So if you want to go for hybrid kind of thing, first of all, you need to know what are the things available. Then you can make it the combination of best fit. So that is like, if you know what is the advantage of different methods. So for your problem, combination will give you more suitable for your particular problem. Those two you can select. So here, evolutionary algorithms, as I told you, genetic algorithms, differential evolution algorithms, graphic-based optimization, evolutionary strategy algorithm, stringent algorithm. We have another classification, stringent algorithm, and self-learning algorithms also there. That is also one part of classification where you will have self-learning kind of things. We will see it in the end. Next, swarm intelligence, as you know very well, you have many more swarm combinations like particle swarm optimization, ant colony, and spotted hyena. So in this also you have two classification. One is birds, and another one is animal based classification is there. So next, a physics based algorithm, that is ecological based, we can say ecological based, gravitational search algorithms, black hole algorithms, chain system search algorithms. So next you have another classification, bio-inspired algorithms. So bio-inspired algorithms will comes under swarm intelligence, and based upon certain features, it has been separated, because in swarm intelligence, it is a group kind of thing. Okay, so based upon a few characteristics only, it has been represented as separately, but otherwise it will be under swarm intelligence only. So cuckoo search algorithm, BAT algorithm, bacterial foraging optimization algorithm are the different categories in this. So in this, we will see the which are the best used by different research areas in our electrical system. So this one more, coming to the applications, you have many more applications. So, and these are the areas. These are the areas and these are the applications. So what are the different areas? We have biomedical, civil, electrical, computers, even your forecasting of your trading, this financial trading of the country also, it has been done by this computing technique. So now, what are the major areas that soft computing technique can be used? So best one is your pattern recognition. Next, process control. That is where you are controlling our like wind turbine. So where you're controlling pitch angle. So and similarly PID, wherever you're using PID controllers, there you need to tune the coefficients, proportional, integral, and what is your decision? You can go with high acceleration position. That is, you can keep complete rotation. That is rotation angle, you can take decision as high. Okay, next, you have moderate irregularities, moderate people on the road, and next you have moderate fuel in the tank. So okay, here fuel is not a matter. You have a moderate irregularities and moderate crowd on the road. So then you will go in a medium acceleration position, medium angle. And next is the if you have full crowd, so it means a traffic jam, completely it's jam. So what you will do, you will keep your position at low. So that is called reasoning. So here what we are doing is in fuzzy logic, how you are bringing things, and we are going to frame the rules. That is how our mind you are framing for riding the bike. So you are framing as a rules. So those are called as fuzzy rules. In knowledge base, we will, that is the expert will store these rules. So either it may be a three linguistic variables, or 5 linguistic variables, or 7 linguistic variables. So why we need to go for those are 5 linguistic variables or 7 linguistic variables? So why we need to go for high linguistic variables? As your problem is more complex, then to use you need to use more linguistic variables, because it has been proven in literature, as you are increasing your linguistic variables, your exact approach, that is desired outcome will be reached, as compared to 3 linguistic variables. 7 linguistic variables will provide a best output. And next, that is the first point you need to remember. Why I need to go for 7 linguistic variables? 5. And one more thing you need to remember, that when you are using fuzzy logic, you have to remember how many input complexity. That is complexity, I can say how many inputs, how many outputs you are having. So based upon the complexity, you need to choose the rules. Okay, one thing, if it's a more complex system, then go for 7 linguistic variables. If it is less complexity system, you can opt 3 linguistic variables or 5 linguistic variables. Because when you go for 7 linguistic variables, the approach is very complex. Okay, So that is one point you need to remember. Next, here membership functions. So this is in my research I have used triangular membership function. So with 50% overlap. So why we are doing this means, so 50% of overlap of the membership function will give you best result compared to the other overlappings. So what it means is that see here, what I mean to say is that is my triangular membership function. So this where you are overlapping. So we will consider this is 0 position and this is 1. Highest is 1 and lowest is 0. So this particular point where you are overlapping it. So that plays a vital role while you are selecting your membership function and solving any solution. So 0.5 will give the best result. So that's why this is also very important when you are setting in MATLAB. So that is designing your FIS file. So there you need to consider 0.5 overlapping. So by default in MATLAB, it will be around 0.5. Very rare cases, they will just slide this. Okay. So next, the best method is centroid method. You have center of sums method. You have different methods for, because here we have 3 phases. Fuzzification. What is fuzzification? You are taking whatever may be the crisp inputs. So what is crisp inputs? So previously I have given example, right? That is your road irregularities and then crowd on the roads. So these two are crisp. Crisp means real world, physical world variables. You need to convert this into fuzzy variables. So what are the fuzzy variables? Those are the linguistic variables. So whether this is low, near, high. So here I categorized as a near high, near medium, negative high, negative medium, negative small, 0, positive small, positive medium, positive high. So likewise, I have taken this 7 linguistic variables, 7 categorization, 49 rules you will get it. Okay. So next, after fuzzification, you need to go for selection of your output. That is how you are selecting. So I have already framed these rules. For example, I told you there are no irregularities, no crowd on the road. So what you are doing? So then you are keeping the position as high. So how it will decide? Because you are a human, you are going to decide it. But how you are using in the system. So in knowledge base, these rules are saved. So your fuzzy inference engine will reads the inputs based upon inputs received, whatever be the rules you framed in the knowledge base. So that particular outcome will be sent as output to the defuzzification. So why we need to do the defuzzification? So here it will give the input as high, positive high. Means high position you can keep your accelerator. So now this positive high is not compatible with my real world. Real world is accelerator position, physical variable. So now I need to convert this particular positive high into highest angle, that is theta value. So this defuzzification mechanism will convert this into positive high. Next, fuzzy, that is here are a few more examples. That is how it actually works. So here I said 0 to 1. We have a range in fuzzy logic, always 0 to 1. If you are saying 0 or 1, that is a crisp logic. If it is in between 0 to 1, then we have this kind of segregation. That is slowest. So here we have I have taken annual symbol, that is your scale is very that is it has the slowest speed. Next, tortoise is a little bit faster. It is a dog which is faster than tortoise, and then it is cheetah which is faster than all these things. So that's why indication wise I kept this, but you need to understand these values. That is important, because if you're going for real world, what range you are selecting it. For example, I said the fastest. Fastest means the theta value should be 0.75 to 1. So that will be given as final physical value. It means that this fastest is your fuzzy variable, that is positive high, whereas this 0.7 to 1, whatever the range you are getting, So that will be, that is the, from the centroid method, that will be the theta angle to be set. Okay. So now here you have one more example like cold, cool, warm, and hot. So here the thing is fan speed. It's a very simple example. You need to maintain the fan speed within the room, that is auto control. So what are the basic parameters? So you're going to sense the temperature in the room and humidity inside the room. So temperature and humidity, these are the two inputs you're considering. So based upon these two, you need to take the decision. So now I have one condition, that is, for example, this humidity is high and room temperature is cold. So humidity is high and room temperature, sorry. So for example, my room humidity is high within the room and temperature is low. Temperature is cool. See, humidity is high, temperature is cool. So temperature is cool. It's not so cold. Okay. So then fan should not be run with high speed. Okay. So for, this is not a cooling fan. It's a you have a heater fans, right? So which creates the hot air in the room. So for that, this is the example taken. So if you see here, humidity and cool. So humidity is high and it's cool. Room temperature is cool. It means that medium value. Then it will give the normal temperature. So if your room is very humid and so cold, then you need to give more high hot air should be blown within the room. So I just given one example here. You can analyze the remaining. That is, I'll repeat once again. Humidity is very high within the room, and the room temperature is observed as very cold. Then your blower has to blow very hot air within the room, okay, in order to maintain the room temperature. So this is one more example about the fuzzy inference. Next, neural networks. So that is a fuzzy inference mechanism, the neural nets. So you know very well about, I need not to explain about this because everybody know about this. I'll just discuss about what are the key parameters here. So you will be having inputs and you have synaptic weights. In physical, that is biological, we will call it as synaptic weight. Here in artificial, we will call it as weights. So next, you will be having a threshold function and output. So threshold function will decide based upon the input summation, whatever the threshold you fixed, based upon that output will be generated. So output region is 0 to 1. So for example, here I have considered this threshold function. Okay, you have different threshold function, Gaussian, and you have linear. You have different functions. So here I have considered that is Adeline network. So Adeline network means we will consider this step kind of that is unit step threshold function for Adeline networks. Okay. Take one example in this. I'll explain you how it really works. So this is a basic one. So how your neural network works. So simple. For example, here you have two inputs. So now here you have fixed either that is I0 or I1 has to be sent as output. So here you are fixing as threshold as 1. For example, this is the same threshold you have taken. Okay. So if the summation is my threshold limit, for example, I'm keeping it as a 0.5. If summation comes less than 0.5, I'll send I0. If it is greater than 0.5, I'll send I1. So here it will act like a auto control. This acts like a gate. Okay. So where it can be useful. So for example, your door. For example, you have a door. So in a door has to be open or close, right? So how you will be deciding that particular thing. So how my neural network will help in opening or closing the door. So here the input is one sensor which has to sense the presence, that is proximity sensor, peer sensor, you can use it here, and that input will be read as I0. And second is my supply should be always there. Okay. So now here I need to take one input as sensor input and other as my supply. So two inputs I'm giving as input. I'm giving an input. For example, my supply is there, and there is a person behind the door. Then it will be 1 and it will be 1. Here I'm considering as 1. Weights I'm considering by default as 1. So now 1 into 1 is 1. 1 into 1 is 1. 1 plus 1 is 2. My threshold, I'm fixing my threshold value as greater than 1. Greater than 1. Okay. So 2 is greater than 1. So output will be 1. This is the threshold function which I have selected. Output will be 1. When it is greater than 1, output will be 1. When it is less than 1, here, this thing I'm threshold, I'm considering as 1. 2 is greater than 1. So I will get 1 as output. If it is less than 1, I will get 0 as the output. So I'll get 1 as the output. It means that the motor, it is initiating the motor. So motor will start rotating, your door will open. Okay. Now when human enters, now proximity sensors reach 0. So 0 into 1 is 0. 1 into 1 is 1. So 1 to 0 is 1. But what is my threshold? Threshold is the input summation value must be greater than 1. Is 1 greater than 1? No. 1 is equal to 1. So it fails the threshold. So then what it will do? It will send 0 as the output. So my motor will close. That is, one is on and another one is close. Okay. So that is how your door will close. Okay. Open or close. So that's how it works. And next, this is one more example for classification. So for example, I want to separate similar kind of things and different patterns. Okay. So for example, 0, 0 is same pattern. 1, 1 is same pattern. 0, 1 is different pattern. 1, 0 combination is different pattern. So now my neural network should give the output such that it has to classify. So what is meant by classification? So same characteristics should be separated. That is called classification. So 0, 0 is same value. So this is one group. Same is one group. Different is other group. So this first one and last one comes under same group. Same, SAME, same. Let us consider same is one group, different is another group. So this first combination, last combination comes under same group, and middle 2, 3 will comes under different combination. So my neural network has to give the outputs in such a way that the same should generate the same output, different should generate the same output. That is what it means in actual is 0, 0 and 1, 1 should generate the same output so that they will be separated. And next 0, 1 and 1, 0 will be recognized. Next it will be separated. So in neural networks, we have a single layer network and multi-layer. So what actual process will happen inside a neural network? Main two things will happen. One is feature selection and next feature extraction. Feature selection and feature extraction. The initial layer always does feature selection and the output layer will always do feature extraction. And you can add some more layers in order to do further extractions, in order to improve, in order to solve complex problems. So now, so here, this is the way which we selected, for example, the classification. Same, for example, here, X1, these are the inputs, and I want to implement this XOR gate, okay, XOR logic. So you know XOR logic, but how to implement this with neural network? That is a big question. So in a neural network, the thing is you need to train the network first so that it will works as per the training. So what is meant by training? Training is nothing but selecting the exact weights to perform the desired operation. So how to select the weights? So that is a big question. So what we will do is we will initially go with the random selection. So random selection means I'll assign all ones. Then I'll train. I'll train means first I will give 0, 0. I'll check out whether I'm getting 0 or not. Next I will give 0, 1. I'm checking whether I'm getting 1 because I need, this is my output logic. So training means you know the input and output. The network should give for this inputs, it should give these outputs. Okay, desired outputs it has to generate. Okay, so keep on changing the weights will lead certain position that is called your optimal position. Okay, global minimum position. So that has to be reached. Okay, so that is how this training of the neural network will be done. Then what is the importance of this bias? So in neural networks, like for example, if you take a human or you take a student. So if you take a student who is pretty much interested about the sports, so his mind is always thinks about when lecturer is delivering some thought, teaching. So he always thinks about sports. It means that whatever may be the incoming, that is whatever the lecturer is presenting on the board, he won't able to understand that because internally he's giving inputs as details about the sports. For example, today Australia-India match is going on. If you want to teach your student about a particular important topic, so that will be only 50% efficiency because to the students like who is having interest on sports. Why? Because I'm saying is his internal bias plays a major role. So internally, so he will add the inputs like what is going, what might be the score, what might be the who will be like that. He continuously thinks internally. So that particular kind of thing, it means that sometimes, for example, you train your student, he's not doing the work properly. So the reason is this bias. So that nature they have included in artificial neural network as bias. So that is the importance of this bias. So with this bias, you can change the output. Whatever may be the combination here you're getting, by deciding this particular bias, you can change the outcome. Next, genetic algorithm. So you know that it's evolutionary algorithm. So whatever may be the input patterns you are giving, the output pattern will be the best compared to the both input parents. So it means that the solution, that is a final solution. Here you will be having 4 steps majorly. That is population, selection, mutation, and final generation. So these are the 4 steps. So this diagram will clearly explain you about how genetic algorithm works. Initial population. So what is the initial things? So initially we will have a chromosomes and genes. So if you consider all the things in binary, for example, this is a pattern which you considered here. So how it exactly works? First, fitness. What is meant by fitness? So it is going to choose, it takes a combination. So 1 with this 0, 1 with this 1. So like it will calculate fitness value. So whichever combination, 1 is the highest combination, 1 0 is the lowest combination. Whichever is giving best fitness, that will be selected as patterns. So this is the highest fitness value, this is the next fitness, this is the next fitness. So these are the populations you have selected finally. Next, you need to have select the best one from this. Okay, so the selection process will be done like this, whichever is highest. So here we are calculating only fitness value, that is the combination. You are going different combinations. So in that, whichever is having best combination, that will be placed at the first. So that will be selected as primary one. So next, mating. So what is meant by mating? In mating, we will have a cross points. So these are called cross points. So based on the cross points, here it will be mate with another combination, that combinations. So here based upon the cross points, the mating will happen. Mating means like here fitness value, the way you calculated, here it is going to rearrange the patterns based upon the crossover points fixed. So this process is exactly resembles with the baby birth. Okay, so so here, for example, 110. For example, here you are taking 110. They have selected first 110. This 110 will be combined with all the patterns, and it will be calculated best fit. So whichever is having highest fitness value, that will be placed at 1. Next fitness value 2. Next 3. Next 4. Next among these, they will be arranged in pattern based upon the selection criteria. So after arranging, then mating will happen. So the mating, so this is the particular selections you have done. So now you are taking the same parents patterns, patterns, and then these will be reallocated. That is called mating, reallocated based upon these cross points. So this green will be sent at one side and these will be sent at one side. So it looks like you're forwarding ones and zeros, but in actual, the behind thing is, so this particular acts like one gene. So these all acts like one gene. So that is one particular characteristic. For example, some people will have doing the nose like this. Some people will have always doing like this. For example, they are just pinching their ear. So that is not their habit. That comes by genes. So here each binary digit will represent one gene. So that will be mated. This combination of genes and chromosomes will be taken into consideration. So each chromosome will have certain data. Okay, so this data will be recombined. So which will be framed for children. So after that, you will be having mutation. So mutation means this is the chromosome pattern, final chromosome pattern for children. So within this, the gene will be included within this particular chromosome pattern. So why? Because so I can explain you in a simple way. Like for example, parent A, parent B, you have two parents. So from the two parents, you are getting the best chromosomes. So for example, he has some health issues, or your father has very good charming face. So that those particular characteristics will be acquired because that is the best fitness. Compare both charming faces. So whichever has highest charming, that will be brought into child. Okay, so that way it will comes in mating. Next, genes. So whichever is the best gene, that is either parent or your mother has a different quality. So that particular thing will be included in the final chromosome pattern. Why? Because it will make sure that the same behavior of the parents should come within the child with some strength. So that is, I can say like mother has some best qualities, father has some best qualities. Those best chromosomes will be taken by the child. So that is called mating process. And mutation means the genes. So you will say he is very lazy because by birth he is getting that lazy, because he is getting some disease, that is by birth, because we say that because of genes he's got that problem. So that is that is because of this mutation process. In mutation, you are changing a chromosome pattern, so which replicates the parent's behavior. So even though, so finally I can say like in mating, the best characteristics will be acquired and gene pattern will be included in order to procure the parent behavior. So that is the reason why mutation will happen. Otherwise, all the children will have the best qualities. Okay, so that is the final generation will come as a final output. So this is how your genetic algorithm will work. Okay. So next, this is a final comparison. Neural networks will be used for your learning and adaptation because continuous change, weights can be upgraded. So in self-organized mapping neural networks, so there will be a feedback. Continuously, these weights will update and their patterns will be changed and decision making will also be changed. So that is, you know that classification, right? Supervised and unsupervised learning. So this is a supervised learning. This is supervised means, you know, you have a teacher, you have a desired output. Desired output will be achieved in supervised learnings. Whereas in unsupervised, that is self-organized mappings. So you won't get desired output, but that will be best suited for non-linear kind of things. Next, fuzzy set theory. Wherever you are going for reasoning, that is knowledge representation. So you need to use the fuzzy set theory. So wherever you have random search, that is which is best, because you know all the inputs and you want to select what is the best, then this is the best option. Then a genetic algorithm is the best option. So comparison with that is artificial intelligence is a different kind of thing. So because there we will give things like images or certain patterns. So it compares the pattern. If it is recognized, then it will gives the output. That is totally different. So here are some more features of your fuzzy system and your evolutionary system, neural networks, and genetic algorithms. That is knowledge representation that is only available in fuzzy logic. Uncertainty tolerance will be available in all the three. Adaptability, this is the major important thing. Genetic algorithm. So because why you can ask me like why neural network is not assigned here. I said here you have categories, supervised and unsupervised. So unsupervised networks are adaptable in nature. Next, knowledge discovery, maintainability. So in all the things we have a maintainability. Now, next, swarm intelligence. So swarm intelligence, I told you, this is one classification that is insect-based and animal-based. So insect-based means ant, bee colony, whitefly, glowworm. So this comes under insect-based. Animal-based, lion, wolf, bat, monkey. You have a combination hybrid algorithms. Now you have birds also. That is crow search algorithm is also there. Cuckoo search algorithm is also there. That is one more classification. You can add it because it's continuously a developing area. The swarm intelligence is a continuously developing area. So it has modifications in when you're going for classification. Particle swarm optimization. So what I will do is I'll just go through all this and then we will go for the application. So particle swarm optimization, so how it will works. So here you will have major three things. One is calculating of fitness of each particle. That is when you have combinations. So whichever, so you will have, for example, you have 4 particles. So 4 birds. So from the side of the first bird, if you have 1, 2, 3, if you name it as 1, 2, 3, 4. So from the perspective of first bird, it will calculate the best fit for acquiring the food. So because all are flying, so then they will watch one particular area. All the 4 birds will watch different areas. Then they are going to calculate the best fit. So whichever is nearer and more. So it has a characteristics also. Food should be more as well as it should be near. So that is a criteria. So it will calculate all the birds will calculate this particular internally, and then so among the 4 they'll communicate communicate each other and they will decide the best one. So whichever is, for example, bird 3 is having very nearer to the food and it has more food. So then all the remaining 3 will follow the bird number 3. So that is how swarms will work. That is swarm combinations will work. So that will be mathematicalized like this. That is, you need to calculate, assign random positions. So you're keeping randomly. Then you're calculating the fitness values for each points. Then which is having the greater best fitness value. So, and again, it will update that best fit value. And again, we will have a global minimum point. So it should be nearer to that. So next, we're going to update the velocity and position of the particle, best value, and that is, I said like third bird. Third bird will take turn to reach the food. So likewise, it is going to in swarm. Next, 5-fly algorithm. So 5-fly depends upon the difference between the major, the basic particle swarm and this is, so there it will be a best fit. Here it is a light intensity because 5 flies will glow light. So based upon the nearer light intensity, so they will take the decision. Whichever is having highest rank, that is you need to go for the parameters. That is what the basic parameters you need to consider. Here in 5-fly, you will have a light intensity and rank. So So based upon these two, it is going to update the best value. Similarly, ant colony optimization. So ant colony is different one because ants will have a paths. So it will go for in different paths. So all the ants will release pheromone within the paths. Okay, they are going to decide. For example, 3 ants went to in 3 different paths. They will release the. They will go through all. They will go through all the 3 paths, and they will gather the data. And they, while they're gathering in one point, they will decide which path is very nearer one. So during the that is going through that path, they will release a pheromone. So based upon that, they will return in the same path. And when they reach the destination, there they will decide which is the best path. That is, best path means which is having nearer and which is having more food. So those are the main criteria. So likewise, it is going to select the best path. So next, artificial bee colony. So this is a little bit different. That is bees. So onlooker bees phase, scout bees. So you will have a different kinds of bees. Okay, scout bees and onlooker bees. So because some will protect, some will carry the this honey. So based upon that is whatever the scout will be updated. So this will all the bees will search for the food. So based upon the data received from the employees, that will be assigned to your onlooker bees, and then that will be forwarded to your scout bees. So it means that all the different kinds of bees will coordinate for the best nearer path and more food availability. PID controllers. So now here we will. Now I'll just give some examples. So now we discussed about fuzzy logic, neural networks, genetic algorithms, some SAM optimization algorithms. Now how to apply these all algorithms to my electrical applications. So first example is PID controllers. That is tuning. This is a basic mode of a controller that is closed loop control mechanism. Here I have used this representation from one particular reference which is more cited. So they have used tuning of this PID for robotic axial rotation using the bioinspired algorithms. That is BAT algorithm, hybrid BAT algorithm, differential evolution algorithm, particle SAM optimization, genetic algorithm, cuckoo search algorithm. So they used all these algorithms for selecting the best values of Kp, Ki, Kd. So these are the 3 values we need to identify for minimizing the error. That is called tuning. So how these will work? So here they have done different parameters will be there. As I told you, like for example, I told you particle SAM optimization. You need to have random allocation of positions. Next, you need to calculate the best fit fitness function. You need to calculate, and then you need to calculate the best fit. So for that, we need to have basic parameters. That is basic initial considerations. So here they have considered the input C1, C2 are the 2 points, and the weights assigned, that is the distance between them, is W, and the location, that is one of the position, that is initially I need to assign the position. So all these things you have to initially assign. Later, based upon the fitness, so this position will vary. Similarly, in genetic algorithm also, there the main thing is population. You need to consider the population. Then you need to consider the chromosomes, gene. So all the 3 things you need to consider here. So here, when you are coming to this particular tuning, so PCPM, here they are considering it as controlling parameter and motional parameter. So controlling, in the sense, here they have considered a robotic arm. So that's why they're considering PCPM initial positions. Okay. Next, they're going to mate how many final tails it has to develop. So that they're considered as T equals to 2. Next, final, that is they need to get the that is primary modulation. This is proximity modulation. Sorry, proximity modulation. So for that, they have set as SS. SS means standard setting. Standard setting means it will be one always. Standard setting. So likewise, for individual algorithms, you will have the basic parameters in every algorithm. Okay, I'll share this particular research paper also, so you can go through it how they work. So here, what you need to understand is when you are using different algorithms, so you will be having, you are designing the code like this. Only thing is you need to select what are the inputs for being able to assign this. So here we are considering in a general terms, whereas when you are going for application, so we need to go for the practical parameter selection. After that, then you are generating your tuning KPKI, KD values. So here, finally, they are selecting this positions of access. There is error-free access. So here they have not represented KPKI, KD values because so in this they have represented only what is the final rotational position of two motors. So in their robo, they have two axles. They have used industrial model. So only two motors they have fixed. So for them, they have two axles. There is axis 1, axis 2. For that, these are the two positions. Two rotational positions they have. They are measuring based upon this final tuning. So next, this is one example I have given. The time is less, so I will close up. So now, for example, electrical applications. So now, what are the other electrical applications? First, you want to measure. For example, you want to go for maximum power point tracking. So in maximum power point tracking, you need to select the best position of the plate or irradiation parameter. So for tuning that, especially you will have two areas in maximum power point tracking. One is tuning of the PI controller. Another one is for irradiation, that is position of your solar plate. So these two areas you can use your SWAM intelligence or bio-inspired algorithms or your star computing techniques. That is the two areas. And next, when you are going for your wind system, so there your the main criteria is selection of pitch angle. So that plays a vital role in wind system. So for selecting of that wind system, generally the basic model is PI-based controllers. So PI-based controllers will be mostly preferred. So they can be replaced with this kind of system. And next, forecasting. So forecasting means that is when you are, for example, forecasting in the sense load forecasting. That is even distribution. That is distribution side. You need to forecast the demand. That is a main challenge for nowadays. So how to forecast that particular demand? So based upon the previous month data or previous year data or recent today's data and yesterday's data, based upon all these things, your neural networks are the best suited for adaptability because they have adaptable nature. So neural networks will be suitable for such kind of forecasting methods. Next, when you're going for this selection of parameters, choosing the best parameters. So when you're saying best, it means that you need to go for this nature-inspired algorithms or bio-inspired algorithms. So when you have a reasoning, that is in which range you need to select. For example, temperature fixing or humidity fixing or water flow. So for these kind of things, fuzzy logic will be plays a major role. So these are the various areas where you can use this algorithms. So and coming to the conclusion, actually I thought of discussing some examples where I have worked. I have worked on ANFIS-based renewable source integration to the grid by maintaining the power quality in three-phase 4-wire system. That is my research area. And now I'm working on smart grids where I'm using with Internet of Things. So there, what I'm doing is this fuzzy logic and neural networks have the best choice, and then the soft computing methods. You will be having the best models. That is fuzzy logic, this reasoning will works in a best manner when you are going to tune your PID controllers, and when you're designing the forecasting using forecasting or any estimation of your currents or power. So for that, SWAM intelligence algorithms will be best suited. So finally, I can say like when you are selecting any particular algorithm, the best thing is you have to do repeated trains. So what it means is, so I cannot say like my BAT algorithm is best, or my fuzzy neural network is best, fuzzy logic is best, or ANFIS model is best. I'll never say, see, I proved that ANFIS is better than fuzzy or neural networks, because whatever the considerations I have initially considered, for that my ANFIS has given the best result. So that is a point where I concluded. But in facts, if you work really on fuzzy tuning or neural tuning separately with different combinations, so that it itself will give you a better result. So that is the only thing I can say when you are going for soft computing techniques. So this is all from my end. If you have any queries, I'm ready to answer. Thanks for your patience.
Thank you, sir, for your valuable session. Now, I request all the participants, if you have any queries related to the presentation, you can unmute your mics and you ask the queries.
Sorry, I need to add the futuristic aspects also. So currently, you know that COVID-19 pandemic, right? So we are engineers. We have to make use of the best always. So even COVID-19 pandemic, which we are treating as a problematic, some of the researchers have studied that COVID-19 expansion, and they found out that that is the best distribution algorithm which can be used in our electrical applications. Already, a few of the researchers recently used COVID-19 algorithm for best distribution. You can go through that. And before last 2 years before, crow search algorithm people are using mostly. So now recently, the COVID-19, most of the researchers are preferring for best distribution, because it has the best distributing quality. That I can add one more point if you are thinking about using latest developments. Yeah, please.
Thank you. I request the participants, you can put your queries in the chat box. You can unmute and you can ask the questions. There is a query from the chat box that is asked by Krishna. How values are changed in classification? We need to write any algorithm.
Sir, 1 minute, sir. What is the query? How values are changed in fuzzification?
How algorithm?
Any algorithm? No. You need not to write any algorithm. 1 minute. I'll tell you this. It's very simple. Actually, I thought of explaining this also. For time constraint, I am not able to explain this. So, in the meanwhile, I'll open this MATLAB. I'll explain you how to do this. It's very simple. So, in your MATLAB, so I'll show you with my research how I selected this. when you open your MATLAB, you can type fuzzy, F-U-Z-Z-Y, in your MATLAB command window. Then it prompts a window like fuzzy toolbox. Just give me a second. Fuzzy toolbox. There, you need to select. So these values, whatever may be 0 to 1, you are taking here. Yeah, here I will explain you. Okay. I'll take a table and then explain it. Yeah. So when you open your MATLAB, there you can see 3 things. One is error E, you're seeing E and change in error E value. Error and change in error. 2 inputs and one more output parameter like this. So here you are able to select. When you click this images, you will be having images like this. You'll be having images like this under E. So E will be like this. Under this, you will be having fuzzification, that is membership functions like this. So when you click this, when you double click on this at the bottom, and at the bottom double click this, there are 2 things. One is you have to change the membership function, and second thing, the pattern how you want to select. Like I said, 0.5 overlapping, or you want to keep it far away from it, or you want to select trapezoid, like this trapezoid, like this. Okay, it's very slow. It's very simple. So at the bottom, you will be having set of rules like this. You will having a standard representation like this. That is negative, high, negative, negative, high, negative, medium, negative, small, 0, positive. Like this, you will be having your linguistic variables. There you can select how many linguistic variables you want to put. So based upon that, you select your, if for example it is only 3, so then you will be having only 3 membership functions will be visible like this. Will be visible like this. So when you select all 5, then you will be having 5 linguistic variables. So like this, only you need to select your fuzzy membership functions here. Okay, and values you are not at all selecting anything, because by default all fuzzy variables will varies between 0 to 1. That's why I said crisp values and you have fuzzy values. Fuzzy values always lies between 0 to 1. The bottom is 0, the top is 1. Always these fuzzy members are 0 to 1. Only you are selecting, you are doing what you are doing. For example, might be your question is like this. So for example, I have temperature 10 degrees. 10 degrees means it's a low, it is a low temperature. Cool, it's a cool temperature. So cool means that is your crisp value, 10 degrees. So the 10 degrees, I need to change to linguistic variable. What is meant by linguistic variable? So in linguistic variable is nothing but, this is the linguistic variable. NH, NM, NS is a linguistic variable. So what is meant by, again, linguistic variable means how it will be represented means it is represented with membership function. So here, it will be visible like small n and h. So this membership triangle, this single triangle represents NH. Here NP. Likewise, when you are selecting a particular value, 10 degrees, that corresponding value will be assigned here. So, for example, I will draw the axis. This is the axis. I'm drawing like this. So for example, this is the highest one value. Here one value is there. For example, let me write this. It's 1, and here it is 0. Here you are taking your temperature value. You are taking temperature value. So for 10 degrees. So for example, here you have a 10 degrees. So this corresponding value will be assigned to your crisp value. So that is how converting a crisp value into a fuzzy value. So what it means is your temperature is degrees. Now you want to know what is my fuzzy value. So the fuzzy value lies between always 0 to 1. So now this 10 is represented as this is NH, that is high temperature, sorry, negative temperature, negative high. Negative high means very low. Negative high means very low. In this, how much it is? It is, for example, here it is 75%. It means that 0.75. 0.75. This is how you are converting your crisp value into fuzzy value. So we will represent this f of x, that is your f of e, that is error, as 0.75. That is one input value, and you are taking change in error. Change in error is another fuzzy membership function. So that value is also represented like this. And finally, here you are going to observe. You're going to observe the rule. What you are finally concluding. Finally, you are concluding as when it is high and it is cold, the output should be high. So output should be high. Then, so high means, so from 0.75 and for example, let us consider 0.5. These are the two inputs you got. For 0.75 and 0.5, we are calculating. We will got finally two membership functions, only two. So one is, everything will be represented, will be like membership function only. This is one membership function, error, and another membership function is, you're getting like this. It means only you are selecting this NH and this ND. For example, these two, high and cold, high and cold. These two membership functions will be combined in in defuzzification phase. In fuzzy inference, these two will be taken, and final one outcome will be generated. That is, this is the area under, this is the only area under these two triangles. So this area, for this area, you're going to apply centroid method, where you are getting some centroid value. So here you will get 0.75, 0.5. The average area under this curve, you may get around this point. This is the point. So this value will correspond to that particular angle of rotation. So it means that in fuzzy logic, what you are doing is you are framing the rules only. Here you are not selecting any values. So you can use the same rules for other kind of for error tuning. For example, you are doing only error tuning means you can use the same rules for wherever you are doing only error tuning. For example, your application is, I need to generate the power loss based upon current value and voltage value. That time you need to select different rules, because these rules are framed for only error minimization, not for power loss calculation. So if current is low value, voltage is different value, so multiplication is the power, we know that. But how much power percentage we need to select, so that matters. So that percentage, that you are writing a particular rules. So for example, the loss current and voltage, line voltage is having different values. So for that, I will have one set of power value. So if loss power is very high and voltage is getting reduced, then my power will have different values. So all these combinations will be selected, will be framed as a rules here. So that is how we are doing in this. So I can say like there is no need to select the values here. Okay, only the thing lies here is you need to select the rules, you need to frame the rules, and you need to select the membership function. So those are the main criteria. So that is my answer. So if it is open, I can explain. I can able to explain. Is it sufficient if you need some more explanation? Vijay Krishna. Sir, can you need some more explanation? So for your question, the answer is no need to assign any values. Only we need to frame the rules and select the membership function and use for inputs output. Any other queries? Because if you want to learn this soft computing area, so what you need to do is, first of all, you need to select one particular problem. Okay, after selecting that problem, then select any two soft computing techniques. Any two soft computing techniques. Don't go for all the soft computing techniques. So select the two and then find out the best values. So then only you will come to one conclusion. So whichever is best. Okay, based upon constraints, again that result will vary. So you cannot say like, for example, you are doing with pro search algorithm and cuckoo search algorithm. You got best optimized value location. So I'm using cuckoo search algorithm and BAT algorithm. I got cuckoo search algorithm as the best one. You got pro search algorithm as the best one. So that differs. You cannot compare. For example, both of us are working on optimization only, but the conclusion does not depends upon what type of method you are using. The conclusion depends upon the constraints you maintain. If you maintain all the constraints same, then only you will we can compare. Otherwise, it has to be treated as separately because every method has its own advantage and disadvantage. That's all from my end. Anything? So these are my contact details. If you need anything, please mail me. I'll provide the information.
Thank you, sir, for your response for the queries. So I request any queries you can post to the chat box. So the resource person is open.
You can unmute and you can ask me. So Vijay Krishna sir, this is what I'm highlighting actually. So here you can change the pattern of the membership function. We can change like this. So here you have a type. So you can change the type. You have Gauss function, sigmoidal function, triangular membership function. Most of the people will prefer the triangular membership function. So based upon that, you can select all the different membership functions for different variables. So here you have an that linguistic variable name MF2. The MF1, MF2, MF3. It is a three linguistic variables considered in this by default. So we are giving different names like low, high, medium. So here they are given MF1, MF2, MF3. So here you need to edit and you can frame the rules. In rule viewer, you can see the rules and you can edit the rules also. So these two editors, we can select the triangular membership function and rules we can write here. After that, you have to export to the workspace. Then you can use directly these fuzzy rules for your application. When you export to your workspace, then you can use it. Always these files should be saved with .fis. Then only it will read it as a. Okay. So Vinod sir.
Sir,
Are there any queries in my?
Hello. So sorry for the interruption. There is a network issue. So I request all the participants. The feedback link will be shared at the time of validation. So this is the last question, and the feedback link consisting of a 25 questions, which is a quiz in which you need to get 60% of marks. The participants who score 60% of marks will be given the certificates. Great, sir. Wow. So thank you, one and all the participants for your active participation. Now I request Vaishnavi to take over the session.
Yes, sir. Well, I hope that today discussions are on the ways that we can make our society a better place. Now, I would like to express our profound gratitude to our management for their presence and support in this session. And also, I would like to thank our beloved HOD and also coordinators for this moral support and guidance. And I'm very happy to express vote of thanks to our resource person, faculty members, and participants who have made this session a great success. Thank you, everyone.